Hello, calculus fans! Let's try to evaluate the limit as x approaches 0 from the right of x raised to the sine x power. This is of type 0 raised to the 0 power. X is going to 0, sine x is going to 0. And 0 to the 0, if you just take it literally, 0 to the 0 is undefined, which means we don't really know what this limit is doing. All right, so we'll follow the method that we talked about in the last video. We'll rewrite this as a limit as x approaches 0 from the positive side of e to the sine x log x. We're just using the identity that we talked about earlier. And just for notation, instead of writing e to some power, we'll write exp and then put the exponent in the brackets. Now, we can always run a limit through an exponential because the exponential is a continuous function. This is now of type 0 times infinity. And in fact, this is always going to happen like this in this stage of evaluating an indeterminate power. So whenever we have a 0 times infinity type indeterminate form, we have to make it into a fraction. So this turns into e raised to the limit of log x over cosecant x. You notice what we did is we took the sine x and moved it into a denominator, and in a denominator it looks like cosecant x. This is now of type infinity over infinity, and we can use L'Hopital's rule directly on this. So when we differentiate the top, we get 1 over x. When we differentiate the bottom, remember that the derivative of cosecant of x is negative cosecant x cotangent x. And we can move things around a little bit. We end up with sine x tangent x over x with a negative. And we can clean it up a little bit more. Tangent is sine over cosine, so really this is limit of negative sine squared x over x cosine x. Notice we still have the exp on the outside, because whatever we get with this, we're going to raise e to that power. All right, this is of type 0 over 0. The top is going to 0, the bottom definitely going to 0. Let's use L'Hopital's rule one more time. So when we differentiate the top, we get negative 2 sine x cosine x using the chain rule. We can differentiate the bottom using the product rule, and we get negative x sine x cosine x. This is no longer an indeterminate form because it's okay to just plug in 0, because in the top of this fraction we'll get 0, but in the bottom we'll get 1 because cosine of 0 is 1. And so that means that whole limit is just 0. So our final answer is e to the 0, which is 1. And that's our final answer. Okay, that's all for now.